Good day learners and welcome to the new chapter of learning. So for today's video lesson, we're going to discuss about the Mann-Whitney U Test, which is a non-parametric test for independent subject design. So to begin with, here is our lesson objectives. A. To define Mann-Whitney U Test and discuss related concepts. B. To differentiate the t-test and Mann-Whitney U Test. And letter C. Use the Mann-Whitney U Test in an example. So to begin with, what is Mann-Whitney U Test? Well, it is a non-parametric test for independent subject designs. It is sometimes called the Mann-Whitney-Wilcoxon test or the Wilcoxon rank sum test, which is used to test whether two samples are likely to derive from the same population. So now, these are the topics. Mann-Whitney U Test, define and related concepts, differentiate between t-test and Mann-Whitney U Test, when should Mann-Whitney U Test be used, and also we're going to use the Mann-Whitney U Test in an example. So by the definition, the Mann-Whitney U Test is a non-parametric test for use with independent subject designs. So independent subject design is a design in which groups of subjects experience different experimental conditions. There is comparison of a control group versus an experimental group, or two distinct groups are measured. So now, what's the difference between t-test and Mann-Whitney U Test? So commonly, t-test determines significant differences between means, while Mann-Whitney U Test uses the medians to test for a significant difference in the location of the sample data. Also, t-test uses the data directly, while Mann-Whitney U Test uses the data in the form of ranks. So when should the Mann-Whitney U Test be used? First is that when data are in the form of ranks. Second is that when data are not normally distributed, or also implies that data are few. Lastly is that when the variances of the two groups being compared are greatly different as indicated by the F-test. So, U sub S and U sub L are the formulas used for Mann-Whitney U Test, where N sub S is equal to the number of measures in the smaller sample and N sub L is equal to the number of measures in the larger sample. So these are the steps in the Mann-Whitney U Test. First is that rank the data using both groups, so the lowest score gets rank 1. Second is that calculate the U sub S first before the U sub L. Third is that look up at the tabular value for N sub S and N sub L in the Mann-Whitney U Test table. Fourth and last is that if either the observed values is equal to or less than the tabular value, there is a significant difference between the two groups. So now for the decision making, if either the observed values is equal to or less than the tabular value, there is a significant difference between the two groups, which means we're going to reject the null hypothesis. If otherwise, we're going to fail to reject the null hypothesis. So to better understand the use of Mann-Whitney U Test, we're going to use it in an example. So our example here is the bird song duration. So here is the list of the data of the bird song duration. We have here sample A and sample B. For the sample A, we have here 4.7, 5.3, down to 4.4. For the sample B, we have here 8.1, 4.2, down to 7.8. So the null hypothesis would be there is no significant difference between the song durations of the two groups. For the alternative hypothesis, there is a significant difference between the song durations of the two groups. Then U sub S and U sub L test, or what we call the Mann-Whitney U test, would be our statistical tool and 5% level of significance. So now we're going to rank these sample. So for the rank 1, we have here 1.8. For the rank 2, we have here 2.7. For the rank 3, we have here 3.6 and so on. And for the last rank, which is the rank 16, we have here 9.5. Then summing up the sample B, which has the least number of ranks, then the total is 68. Then we're going to count the number of ranks in each sample. We have here n sub s, which is 7, and n sub l, which is 9. Again, where n sub s is equal to the number of measures in the smaller sample and n sub l is equal to the number of measures in the larger sample. So substituting the value for the formula of u sub s, we have there 7 times 9 plus the quantity of 7 times 7 plus 1 divided by 2 minus 68. By simplifying, we got 63 plus 28 minus 68 with the difference of 23. Now for the u sub l, we have there 7 times 9 minus 23, which is 40. So now we're going to look at the tabular value for the n sub s and n sub l. And remember, it is two-tailed. So by locating the n sub 2 and n sub 1, we can get there 12. So again, with the computed value of u sub s is equals to 23 and u sub l is equals to 40, with the tabular value of 12 at a 5% level of significance. Since the computed value of Mann-Whitney U value u sub s and u sub l of 23 and 40 respectively are greater than the tabular value of 12, therefore fail to reject the null hypothesis. That would be our decision. So to conclude, this means that at 5% level of significance, it can be concluded that there is no significant difference between the song durations of the two groups. That ends my discussion about the Mann-Whitney U test, and this is my reference. Thank you for watching, and I hope you learned something. Goodbye!